We are very fortunate to have my friend and the polymath Professor Morten Kringelbach. Thank you very much.
Thank you so much. I mean, it's so wonderful, isn't it, to think that tomorrow is solstice, and you know, it's a wonderful day to be doing this. And I want to talk to you about why it is that music is so meaningful, even perhaps flourishing. I'm a professor of neuroscience in Oxford, but I'm also a professor of music and neuroscience at the Center for Music in the Brain in Denmark. We'll get back to that in a moment, but what I'm really interested in is to try to understand what it is that gives us meaning. Here's a quote that some of you may know. What is the meaning of life? That was all a simple question, one that tended to close in on one with years. The great revelation had never come. The great revelation perhaps never did come. Instead, there were little daily miracles, illuminations, matches struck unexpectedly in the dark, and here was one. So that's really what we do in my center, is to try to do that. And of course, those matches that are struck unexpectedly in the dark, in the most unusual places, perhaps one of the most important of those matches is exactly that of music. And in a moment, I'm going to show you a small video that really says everything I need to tell you, and you will immediately get why it is so important. So let's have a look at these two little girls.
Hi, girls. It's August 6th. Is that right?
Yeah.
August 6th, 2012. Daddy's going to play them a little song while they're eating their peas.
You guys ready?
Wow, huh? Amazing, huh? I mean, so what is it that is so special about them? I mean, of course, they're extremely cute. There's also something going on here. I mean, she's realizing there are more peas to be had, right? Yeah, so there's competing interest, and yet, of course, they keep looking at each other, looking at their father. And in Senegal, there's a language called Wolof, Senegal in West Africa, which means people are people's medicine. And I think this is what we're looking at here. This is how it is that we use music as a way of getting together. In fact, interestingly, the word garabam means both medicine but also tree. So people are people's trees. So I think when Virginia Woolf was asking about what is it that is meaningful, she was really talking about the large tree in our lives. And in my research, I've really been fascinated and interested in how it is that emotions helps us do that. What are they for? Why are they there? Turns out that they're really important for when it comes to how the brain solves all the problems that are around us. In my work, I've been reverse engineering the brain. I've been interested in how it is that the evolution has built us as a sort of a hierarchical orchestration, that somewhere in the top of your brain there may be some wise elders that are running things. Because, of course, we need to solve problems very quickly. And one of the ways that I've come to this is through the pleasure cycle. And I'll tell you more about what I mean by pleasure cycle. But crucially, once something goes wrong with that pleasure cycle, once you no longer like music or no longer like peace, you basically don't really feel very well. You get anhedonia and you get depressed. Now, on the other hand, there's something really key to what we do, and that is we predict all the time. And I'll try to convince you that music is a great example of how it is that we predict things and we expect things. In fact, some people, like David Huron, who sadly died about a couple of weeks ago, earlier mentioned in Milton's talk, he said music is sweet expectation, sweet anticipation. So before we get there, though, we have to talk a little bit about Aristotle, because I'm an Aristotelian sort of in my heart of hearts. So he had this idea that there's something sweet out there, something he called hedonia, from hedus, the sweet taste of honey. Those are the kind of things that makes us survive, like the peas, like the food, so the peas, the sex, and also social things. Obviously, there's no music there, and music could well come in with his other idea, namely that of eudaimonia. Eu meaning good, and daimonia meaning spirit, the good spirit. Those are the kinds of things that are subtle and complex, and yet that's the reason why you got up this morning. So let's think about how it is one can study them. And in my center, we study them in many ways. through psychedelics, meditation, but also music, and it's music that I'll talk to you today about. But first I'll just show you the only part of the brain that you can see with your eyes, namely your eye. And these are 3 generations of pupils, and what it is that they see, of course, is the interesting question. So when I show you something like this, most of you won't be able to make any sense of that. You don't have a template as it happens. But all I have to do is show you this image of my 2 little girls sitting in the sun, and suddenly you can see those 2 girls, yes? You've immediately built your own template. So if I show it to you again, you can see it. Same thing, of course, happens in the brain. Some of you may know about these things called cochlear implants. Small implants that allow deaf kids to actually hear. The way they do that is they take the sound that you're all hearing, and then it's being downsampled, and then it's being fed into the cochlea, and the brain is learning to hear that. So what somebody with a cochlear implant hears is this. Anybody made any sense of that? It's very difficult, right? It's a bit like those 2 kids sitting there. But what if I play you the non-degraded version?
The wife helped her husband.
And I now play you the other one. It's like magic, yes? Immediately, because you now have a template, your brain is able to make meaning of it. And the question in my research is, how do we do that? Well, first of all, the brain anatomy is hierarchical. As you can see here, it's thinking about it like a pyramid. So these are the levels of the hierarchy. These are the lowest one. This is the highest. If I now just show you that I can turn this pyramid around so that you see it from the top and down. So these are the lower levels, these are the upper levels. If I take something like the visual sense, and over here you've got the brain, and you see the red part, that's basically how visual input comes into your brain and sort of slowly gets to the front. Similarly with the auditory sense, which of course is important for music, it comes in through the blue part, the auditory part. And then eventually they come together at the top of the hierarchy, and it allows you to make sense of those things. At the same time, though, what are the things that makes us make sense of that? The old map makers were talking about when they were making maps, when they didn't know where there were things, they said, here be dragons. So really my work is about finding those regions, the wise elders at the top of your hierarchy that make sense of this. And by the way, when I showed this to my good friend Annie Catra, who's an artist in residence, she said, why don't we make some sculptures? And you walk over to the Wellcome Museum, you can actually see the sculptures that we made from the 5 different colored regions of the brain that is lowest at the hierarchy. Okay, well, I mean, that's all well and good, but how do we value these things? How do we make sense of them? How do we like them? So right now, for instance, I haven't had good coffee, so I'm right here wanting to basically run out of this room and get some good coffee. Once I've had that coffee, I may get quite a large amount of pleasure depending on how good the coffee is, and then I can start doing other things. So this is what I call the pleasure cycle, and our lives are basically shaped by this. And one of the the challenges is to find out what part of your brains are basically working to do this, but also making sure that we can make that phase transition. So in order to survive, we need optimization of resources. We can only do a few things, at least those of us who are men, concurrently. And the wanting, the kind of coffee that if some of you had that little piece of coffee, that would immediately be like a motivating magnet for me to think I need to really run out of this room now. But importantly though, that pleasure that I know that I'm going to get, the expectation of having that pleasure and actually getting that pleasure is what drives me to do things. The man you saw at the top right corner is Kent Barrage, and he's done experiments like this where he's given sugar water to babies. I'm not sure how he got Essex for this, but they lick their lips to the sugar water to get as much sugar from the lips. Now, rats do exactly the same thing. And you can do things to rats that you wouldn't necessarily do to humans, and you can find out what it is that actually makes them do that. But with the yin, there's also the yang, and I'm not sure how he got, this is how we teach Danish kids to drink beer. It's kind of bitterness that at some point gets linked to something that is presumably nice. You find exactly the same in rats. Also notice over here, sometimes it's difficult to tell, is that a woman in deep pleasure or deep agony? But once you start then doing experiments in rats, you can start to look at parts of the brain that are involved in these 2 aspects of reward, namely the wanting and the pleasure. And you can start to think about where that might be. This is the region of the brain called the nucleus accumbens. And in the nucleus accumbens, you can basically stimulate with opiates that we heard about earlier, or with optogenetics, so direct stimulation, in the red part. And you can, like a dimmer switch, make the rat lick its lips more to the same amount of sugar water. On the other hand, if you stimulate it in the other part here, you can turn it down. So in other words, this is a really important part of a larger circuit that drives how much you like things. And if something goes awry with this, you get anhedonia. You no longer like the things you would normally like. And like Kent has done a lot of this work in rats, I've done a lot of work in humans. I've looked at food, I've looked at social, I've looked at amphetamines, I've looked at gambling. I wanted to look at orgasms in the scanner. Unfortunately, as you know, we close our eyes and think of England. So it was very difficult to get ethics, so I had to not go to Denmark, where we also think of England, or something else. I had to go to Holland.
Everyone thinks of England.
I had to go to Holland to do the orgasm studies, but I'm not going to talk about those today. But of course, they're directly linked to what we talked about earlier when it came to the actual experience of the musical orgasms, the chills. But if we just for a moment think about the most important part for your pleasure, which is the part just over your eyeballs, it's called the orbital frontal cortex. Orbit means the eyeballs. This is the part of the brain that I've sort of made my name on initially, because nobody else could get signal from it, and you know, amongst the blind, the one-eyed is the leader. So I was able to actually map this part and find out what it is that it's doing. The other thing I would say to you, if you ride a bicycle, wear a helmet, because this is the part that could get in trouble if you fall on your bike. And if this gets in trouble, all of the kind of things you normally like could well go out the window. So wear a helmet. Now, importantly, this is not the only part of the brain that is doing things. As you can see here, where I've got the rat brain on the left and the human on the right, you can see there's a circuitry of different parts of the brain that are important. And just like an assembly of people, it decides whether something is nice and whether you want something, whether you like it, and whether you can stop liking it. And it also means that there's no real difference between Bach, Taylor Swift, and, say, orgasms. In terms of the brain, it's the same circuitry that is running that. It may feel very different, but in this machine room of the brain, this is how and this has to work. And so, of course, this is where things got interesting, because for the years I couldn't get people to really care about pleasure. So I thought, why not make them care about something really important? And this is my center in Oxford, the Center for Eudaimonia and Human Flourishing, where we move beyond just the pleasure to think about the meaningful pleasures. And I encourage all of you to come. We have a great solstice party tomorrow, where we will have a big bonfire and make merry. And in this center, we have this interdisciplinary team full of all sorts of people, including musicians like my good friend Milton. And we want to find out what is it really that goes on with pleasure and flourishing. And we use all kinds of different methods and theories. This is my advisory board. These are some of the people that are in the center, but most importantly, these are the artists in residence, and you immediately recognize the man with the guitar, the man who has one of the titles I would love to have, namely Professor of Jazz Guitar, but he wears many hats, as you know. There's another person here that I absolutely adore, Tim, who's also in the audience today, who is one of the most extraordinary photographers of animals in general. And he basically lets the animals speak for themselves. So this is really, I think, flourishing, if you're serious about it, it's not just about putting people in brain scanners, but actually look at what happens when it is that you are engaging with all the disciplines. So in many ways, very much like Gresham. So in the center, we have 5 different ways of looking at things: sensorium, nurturing, music, psychedelia, and meditation. And the thing that we're going to talk about today is music, but the other parts, of course, if you come to the center, I'll explain more to them about. But the key thing here is that each of these tell us something about the aspects of flourishing, whether it's taste and smell, which creates those kind of emotions, whether it's the nit-nitai garabam of parenting and why those kids were so cute, whether it's the playing and dancing and improvisation and listening to music, or whether it's the kind of meaningful experiences that you get from psychedelics with or without music, or perhaps even how you can create your own states through meditation. But the reason why we can make headway with this is because we've built these brain models. And just bear with me for a couple of minutes where I'll just explain to you what I've done with this amazing connoisseur of coffee, Gustavo Deco, who's from Barcelona. Everybody should have a friend in Barcelona. And what we do here is we actually make sense of the kinds of images that you have here. This is a larval zebrafish. and you see all the neurons going at the same time, and you can see that these avalanches of activity that changes from time to time. And the big question for the brain is, how the hell do we do so much when we are so slow? It may not look slow, but how do we make those kind of avalanches of activity? So how do we survive, in other words? And the only way to know that is by building a model, as Richard Feynman would say. And here's a model of basically, it's a big sculpture that you can find in LACMA in the US, in Los Angeles. And as you can see, there are lots of kind of traffic running around those tracks. There's even a woman taking care of everything. She could be like a wise elder, and you'll see in a moment that she may be the one we're looking for. So if you think about it, this is like a brain. You've got the road net, it's the architecture where things are running in your brain, and the actual traffic is the brain activity. The only difference with our brains is that in our brains, we can constantly change the road mapping by using something called neurotransmitters that we've talked about earlier. So these are the roads, this is the traffic running on those roads. And then once you know that, you can start to build models where you take your data from your time series and you put them into a model. And then once you have the model, you can start to think about how it is that the different parts are important. So you fit your model by taking the road net, you put something in each little part. You model it and fit your data, and then you can ask yourself, once you have your model and it's producing the same data as in the scanner, you can take things out or you can put things in, and you can find out which part is it actually that are doing things. And we can, as I say, change that immediately by changing the underlying neurotransmitters. But that's a lot. Let's apply that to music. Here's something you've heard before. This, of course, is the Beatles. And in our center in Denmark, we really love Beatles. If you were ever to apply for a position, we would ask you Beatle questions, I'm just saying. This is my friend Peter Wust, who is the director. And what we're interested in is how is it that melody, harmony, and rhythm come together in our brains to basically change these brains. And this is where Milton will...
What's extraordinary about what you're saying about prediction and time-critical aspect is that music just relies on that. It's our will to survive, which sounds like a tune, I think, that helps us make music, basically. So, for example, if I play this, everybody and their dog knows when the next one's coming, so you immediately set up this grid. But you can even put gaps in it. And what you're building are these virtual structures. And the brain is so clever that it's basically being as efficient as possible with prediction. You can think of them as little waveforms where you build up, you're expecting something and then you're not expecting it. But we're doing this on multiple levels. We expect pairs of notes. And then we might expect pairs of notes. So you get this, I don't know if you've listened to music and you feel that there are certain beats which are more important, more cathartic. And this helps us understand this. You can think about listening to rhythm, for example, on a 4/4 beat, and this explains why we have strong beats, because our multiple layers of prediction are coinciding. So that's why when we reach a big downbeat, it feels more important than bar 2. And the best way I found of demonstrating that is to have this circle here. The inner circle moves every beat, the next one every 2, then 4, 8, 16. And so the more dials that go past the 12 o'clock point, the more cathartic it might feel. Now, there's no chord changes. There's hardly anything that happens when these turn. It's just syncopated and groovy. But maybe you'll feel a sense of catharsis when we get the big dial coming around. Ready? Turn it up, Jeremy. Big. You can feel it coming, rising, even without looking at it. Here. And you're moving along this waveform. Another one here, not as big. And you don't even have to look at it, but you'll feel this thing rising in your body.
Some of you may even start dancing.
And this is the essence of groove, is that it gives character to every point in time. They're not even. Let's wait for the last big one. Turn it up for this, we might get a chill. Yes. And what's extraordinary is that we're doing that on the beats level, the half beat level, measure, hypermeter, and so on. But we're also doing it at the micro timing level, faster than we can think, really, and respond. So a beat is not just this point in space, it's a curve. Charles Mingus said that, other jazz people have articulated that fact. For example, this is Django Reinhardt's playing, and this is his favored parts of the beat. This constellation, he liked this sort of honey swing around here. But let's use an example that you will know from Nina Simone. You know, My Baby Just Cares For Me has this distinctive swingy pattern. It goes like this. See, they're not even, right? But bounce, they bouncy, bounce. Now, normally when we think about that, we like to think quite rationally, in that we take the beat and we might think that that swing happens 2/3 along the way. So here is 2/3 along the way. Bouncy, 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 bouncy. Sounds swingy. Here's 3/4 along the way. Da, da, da. Nina goes between these two. And it's a nudge of 22 milliseconds. Give us a sense of that. Way faster than the blink of an eye. Blink of an eye, 150 milliseconds.
Yeah.
We can't even respond. If I want to catch something, it takes me 200 milliseconds to
You
grab
can
it.
never catch Nina.
But you'll hear this subtle difference. Syrupy. Which just stays there and sings on top of it. It's extraordinary virtuosity.
My baby just cares for me. She's a hard act to follow, but still, you know, that's what we try. And who better to follow her than this man, James Brown? Or as some of my students sometimes say, is that Obama? I mean, what the hell? So, Steven Pinker, famous guy, famously said, music could vanish from our species and the rest of our lives would be virtually unchanged. I mean, I respect him, but that is a load of bollocks, if you pardon my French. And why is it a load of bollocks? Because groove, of course, is what keeps us here. And again, who better to give us that but the man himself? Listen to this.
Get down with my girlfriend.
Why is this so groovy, funky even? There's a lot of ears wiggling here. This is because there's a meter here, and then, as you already heard, there's a syncopation that sits just behind it. And we thought, what would happen if we took the classic funk breaks, and we just took the ones where there was very low syncopation, so it was very much close to the actual beat, but close to the meter. It would sound like this. Would you want to dance to that? Maybe with a handbag? Yeah, you could do that, but it's...
I'd be against the wall, probably.
So that's okay. But it's not that funky. But what if you shift it just a little bit and you now have a little bit more syncopation? Yeah. So a little is not good. A lot is even better, right? And this is why my daughters always say, come on, Dad, don't do that dancing.
Go for it.
Fantastic. So a little is not great. More is a little bit better. What about a lot of syncopation? That must be like Mount Groove, yes? Do the snake, right? So that doesn't work. And why is it that it doesn't work? It's because we are in that pocket, but now we are climbing Mount Groove. This is the wanting that I talked to you about earlier. This is the low beats, and this is the medium, and this is the high. We really want to dance to that. And not only do we want to dance to it, but we also like it. Why is it that we like that? It's simply because it sits in that beautiful pocket where we are getting exactly not what we want. We still are able to sort of predict what happens. And so you can then do the mathematics of music, the mathematics of groove. You can take the syncopation, which is the difference of something happening to the meter. You see that just increases monotonically. If it's far away from it, you get a high value. If it's low, you get a low value. Now, on the other hand, if you look at the meter experience, pi, the precision of the prediction, as you move away from it being predicted, then of course it goes down. And if you multiply those two, you basically get prediction error or the musical pleasure or the Mount Groove that I just showed you. And so you can, if you were a geek like me, you can actually write the mathematics of groove. And now what can we use that for? Well, one of the things we can use for is to think about how different kinds of music work. So in classical music, there's very little syncopation. It's the devil's work. It's like, Elvis wanting to move, only being able to see from the top, right? We can't really have the body in classical music. So the way that we create predictions is by changing the tempo stability. Lots of sort of ideas come to mind immediately, but you can see how that works. On the other hand, if you take jazz, you find quite a lot of syncopation in here, and you also find a sort of a fairly steady tempo. So that's another way of doing it. And a final way, just as an example, is the groove that I just played you. Lots of syncopation and a completely steady tempo. So those are different ways of making us want to move. And in fact, in many languages, including Wolof from West Africa, they use the same word for dance and for music. This is one of my students, Olivia, who has written this tome of a paper that if you're ever interested in how music and dance and what has been done in it, this is the one to read. And so how is it then, if we go back, zoom out, and forget about music for a moment, but think about how it is that you become conscious of this. You've seen this before. You've seen this circle, so this is your brain seen from the top, the hierarchical levels. This is a theory that we owe to Jean-Pierre Changeux and Stan Dehen, where you get things coming in from the present, things from the past, things of value, like I've spoken to you about, things that we are focused on, attention on, and then we do something in the world. But at the top of this, there's a global workspace, a group of wise elders that are basically taking in the information and allowing that to flow into the rest of the world. And we did this in over 1,000 participants. We gave them auditory tasks, we gave them visual tasks, we had many other tasks, and we looked at and rest even, and we looked at what are the brain regions that sit at top of the hierarchy. Here's some math for those of you who are into that, but basically we use what is called Granger causality to find out how different regions are controlling each other. Is X controlling Y, or is it the other way around? And when you do that, you can create a great big matrix, and from that matrix you can basically find what I call the wise elders orchestrating consciousness. This is emotion, this is gambling, this is language, this is motor, this is relationships, this is social, this is memory, and this is task. And look how similar they look. You find at the top, you see all the red parts are the parts of your brain that are sort of well protected because they're in between your two hemispheres. And then below you see the subcortical areas that are well protected. Again, if you fall on a bike, they're unlikely to be that necessarily damaged. And so these are the wise elders sitting at the top of your hierarchy. And these are the ones that makes you appreciate, that makes you do meaningful things in the world. And really, that's why we're here. We want to understand how it is that we allow that to go into a sort of a hierarchy of meaningfulness. And then, coming back to the previous lecture that asked the question, what about those other animals? They clearly have very similar kind of things. They don't have language necessarily to speak of. They may have ways to communicate, which is absolutely necessary as well. But of course, they have emotions, they have pleasure cycles, just like us, as you saw in the rat. But do they have music? I think we saw some good evidence that maybe they have music, but it's certainly a music that is different from ours, and yet we can train them to do extraordinary things. So here's another one of our fellows from our center who did this amazing experiments with the one funky seal, and please feel free to dance along with the funky seal, but ask yourself the question whether this seal is doing it just because he wants to make a fool of himself like me, or because there's something at the end. You ready? Look at that sense of rhythm, huh?
It's definitely in time.
It's definitely in time. But look at the very end of it. You'll see something come out, and then you realize, whoops, and there's a bit of fish there. So, in other words, music is not for everyone. Some of us can learn to dance, some of us may not be able to. These are the people that did some of the work. And then finally, for those of you who are really geeky, I've got a new book coming out soon, which is called Whole Brain Modeling, The Cartography of the Dynamics of Mind.
Nice cover.
Thank you.
Perfect. Wonderful. We should get some questions, but I'll get one in first. What's fascinating about this inverted U is that independently, we were working on similar things from different angles. I was interested in what made something groovy. As a musician, I know nothing about the brain. Not even sure I have one. But I knew what felt good. And it turned out what felt good had some objective measures. You know, there are positions of swing and correlations and so on that are amazing. And it's incredibly complex and intuitive. For example, the Beatles, one person might be swinging, the other person might be straight. And if you do it any other way, it doesn't sound right. So what's extraordinary is that, and what's very much in the theme of today, is that we sort of came to similar conclusions. And musicians are doing the right amount of dissonance, the right amount of surprise in music. So what do you think the future is of musicians being involved in such research? Because the problem I've seen with neuroscience and music, not yours, of course, is that it's MIDI notes played in an fMRI scanner, which is not an enjoyable experience, so it's not the actual experience of music.
Yeah.
So what's your thoughts on that whilst I get the next one teed up?
I think it's exactly on point here. I think really we owe it to ourselves to actually study the real pleasure of music and to collaborate. I mean, one of the great things about both the center in Denmark, but also my center in Oxford, is that I think we really need to engage with the highest levels of musicianships. And I think one of the joys of actually having you here is that you bring that to it. And I think one of the wonderful things that you do is that you have such an open mind about what is it really that brings us pleasure. And I think one of the great things that have brought me pleasure over the last 2 years is to watch your lectures, right? Oh. It is true though, right? And I think what is incredible about this is the way that it moves us, right? And I think I've shown you that what moves us in our brains is also what moves us in our bodies. And I think that embodiment is really what we should be looking for. One of the things I would dearly want to do, I showed you that paper that my student had written with me on music and dance. Surprisingly, there's no good data of what happens when people dance. I want to actually have partner dance, and I want people to actually find out what happens as we are grooving. So I think that's one of the great things, and of course you can't really groove just to MIDI notes, right?
No, and what's, that thing of the waveform coming up, that's something that we learn as musicians, you learn to count each beat. And then you don't, if 4/4, you don't have to count each beat, but then you start feeling 4 bars. And it's definitely feeling, I can vouch for it, that I can go 4 bars, go by. And then at Berkeley, I played maybe 50,000 choruses of the 12-bar blues. And so for me, that's a landscape that comes through. I won't ever get lost in. I'm not counting at any point. It feels like these areas. So we've done musicians do things to their brains and hack the circuitry to make topologies, perhaps.
I think very much so, and I think it's not, of course, just music, but it's in all our endeavors, right? That where we basically, when we become expert in something, we know how to build those templates. But I bet you, even though you played all those bars of blues, there are still times when blues can surprise you.
Of course.
When you can get moved in a way that you hadn't expected. And I think those are the moments we live for. Those are the meaningful moments that we are after.
Sorry, if it took too long.
I wanted to ask about the neuroscience of it, sort of like your brain. You showed various models of what's active in the brain. So your senses, your sound, your vision, all that stuff is going into your brain very quickly. And then you talked about the elders. Well, the processing consciousness part is trying to put it all together, right? Mm-hmm. And maybe it's slower than it's the speed at which it's coming in. Is music produced by, it's not necessarily an input, right? It's produced by the conscious central part. Right?
Absolutely. Just a bit like with pain, Pain is not something that necessarily is in the pain receptors, but something that your brain is making up. And so, in other words, something we call it the predictive coding model, is really music is what happens as the input meets your priors about how the world works, what it is that a blues should sound like. And the moment you play around with that sufficiently, suddenly you go, wow, that's interesting, I've got to pay attention. What I've tried to show you is that not just music, but that happens to all our senses, yes? And again, I think the orchestration of that is really what we're after, because at the end of the day, I don't care so much about pleasure as I care about the meaningful pleasures, the kind of things that keeps us around, that makes you on a hot Friday come to this place and enjoy the very special nature of music, yes?
What effect will AI have on music and composing? music?
Oh, that's a wonderful question. I'm so happy. It's almost like a planted question. So, so a lot of you will have been very impressed by ChatGPT, or perhaps even some of the later ones. I think they're a bit like politicians. You know, they're all fluff and nothing underneath. And I think the best thing is if you take these LLM models, and essentially, as you know, these are basically one-step prediction models, right? If you look at the kind of music that they produce, I have yet to hear anything that I find even remotely interesting, because it just lacks that substance. It's the funny thing with language, you know, we listen to our politicians and we are fooled by the way they sound, yes? And we forget that you need to have a substance. We are not that easily fooled by music. That doesn't mean that we can't use AI as a great tool for creating great music. I'm sure that and in fact, I have used it for various things, but it is a tool. Because at the end of the day, music is about emotions, it's about creating meaning between people. People are people's trees. And it may well be that we can have something that can prop up that tree, but I think that's the role of AI.
I think it's very interesting with AI because similarly to what happened with computers, we thought the height of intelligence was being able to play chess. Well, that was the first thing that computers managed to crack, and everyone's phones can kill 99% of the public. However, getting a machine to identify something as a chessboard and pick up the piece and knock anything over is almost impossible. So what we think is hard turns out not to be. What's strange about ChatGPT is I find it quite emotionally mature and really, it's the opposite to what I imagined. But if I ask it to get a particular reference, it can make up utter bullshit. So it's amazing.
So
we don't know
a politician,
what intelligence is.
Brexit.
We don't have a sense of what intelligence is. And also one thing to say about music is that I think there would be a point when they could do impersonations, particularly of music that's generic, because it has enough to feed off. What's interesting about composers who have lasted is that they have such diversity between pieces that when you have a Bach assemble piece, it sounds like nonsense. But if you want the film's underscoring, it's absolutely fine. But it might get better at it. It might get there. But then we have these things called cars, which means we don't have to walk. Yet that's the greatest pleasure, is to walk through the hills, and people still sprinting and running. So we should make music because of the experience and forget about the content of the end of it.
I think that is so true. And in fact, your recent lecture on Bach made me think a lot about that, because there's such depth. There's such, I mean, you think you know Bach, and then you hear it on a different instrument, you hear it in a different setting, and suddenly it gives you back something. And I think that's what I'm saying when I'm saying that the current generations of AI has not created anything of that depth. And what really surprises me in many ways is that Bach, again, something I learned from Milton's lecture, is that between 6 and 7 in the morning, that was the 1 hour that he had to do, because he had to do all this other dross during the day. And yet
he go to board meetings to teach Latin.
Yeah. So in other words, there's something there. And the amazing thing, and this is what really obsesses me at the moment, is how the hell do we do this on such a low budget? You know, use the energy of about 20 watts is like a low, sort of like a light bulb. And yet you do all of this magic. I mean, think about what it is to even do a single search in ChatGPT. Think about how much energy that uses, and why are we allowing that?
And there are farms all around around the world.
So again, I think there are some ethical questions that we need to sort out as well. But that's another day and another talk.
I was just wondering if there's any difference what's going on in our brains between when you're listening to music as part of an audience and if you're listening sort of solo.
Absolutely. And there's even a big difference for those who perform. So one of our professors in the center is a guy called Peter Keller. He had this boys' choir sing a sort of a piece. And there are certain ways in which you can actually see whether they're peacocking, the way that they use their voices. It turns out that it's an evolutionary thing, and the voices change slightly if there are women in present. And so what we did was we had them play just to a normal audience, and then we had 6 really good-looking women sitting in front. And surprisingly, it completely changed, and everybody agreed that this was probably one of their best performances. So that's kind of interesting, and it also speaks to this thing that we'll come back to over and over again. Why is it that we have music in the first place? It's clearly a byproduct of this pleasure system that we all have, this machine that has to work, but it's also something in and of itself It's a language of the emotions. It's something that moves us in ways that are unexpected. And I think, most importantly, it's joyful. Initially, when I started all this work, some of my colleagues in Oxford, they looked at me and said, Morten, are you sure that's pleasure? Is that even science?
That's exactly how they sound.
Right? And I think it is, and I think one of the great things about music is it really allows you to do that, but not just the pleasure, but also all the pain, all the kind of suffering. Because, of course, it's equally true that you can't have flourishing without suffering. In fact, many of us find that it's only when we've gone through a lot of suffering that we suddenly find that kind of light in the dark, that suddenly illuminates the suffering that we've gone through. And I think one of the things that great music does is exactly reminds us of that. It's almost like it's a dress rehearsal to the kind of suffering that we know that we will have to go through.
And that sort of reenactment of the worst and best parts of our life is deeply consoling. We should ask ourselves why, if we see someone being hurt, that makes us feel bad. But if we hear a piece of music which is in response to being hurt, there's something consoling and almost triumphant about it. It's because it seems to surpass the experience to that sort of the elders of the brain.
I mean, I think in some ways, of course, sad music can be thought of, and again, David Huron, sadly no longer with us, said it's like a simulation. It allows you to prepare yourself for that moment that you know is going to come or has happened. And it allows you to sit with that emotion and show that emotion. I mean, again, I think especially for us men is one of the few times where we can really show emotions. I mean, of course, we can't normally when we go to, say, classical concerts, we can't stand up and do the kind of dancing we do at home, and we certainly can't cry either. But yet it allows a space for us to express those emotions that are very much part of who we are.
Thanks. Very quickly, a few days ago, there was an incredible announcement in Scientific American that it's been seen by various scientists that the brain glows. There are apparently thermotubes and all the rest of it. They can detect this. I don't know if you've heard anything about this, but I would love to see how music might change the glow of the brain.
Oh, what a wonderful way to end, yes. I think the glowing, unfortunately, is not yet in human beings, and yet I feel today of all days that
But the
is really
zebrafish was that normal light or was it enhanced?
So that was calcium imaging. So,
Okay.
But I think, I think there is glow here. There's energy in this room that some of it we may be able to catch with brain scanners, but most importantly, we can all feel it, yes?
Yeah,
and
it's not all glow,
really
it's visual, right?
Yes.
And actually, there was amazing images you have of people listening to Piazzolla, where it looks like a tango dance in the mind, because all parts of emotion and prediction and movement conspire together. Can we thank Professor Kringelbach one more time? Thank you so much.